Okay, question 7, typically quite stoichiometry heavy, but again, like you see, first question, definition, you must learn your definitions. It's an extra 10% if you learn at least some of them, I suppose. A strong base dissociates completely in water to form a high concentration of OH minus ions. A base makes OH minus, so if strong base makes a lot of OH minus. They say that you will accept if a strong base dissociates completely in water. Okay, so but you see, the issue is, for me, this was only accepted later. So basically you have to pay for a remark if you want to be guaranteed the more accepting version of the memo. So this was only accepted after the first however many were marked, and if yours were marked earlier on, you didn't get this if you wrote that as your answer. It's not a lot of money to have it remarked, so I would suggest you almost always do, unless you got something like 65%. But anything close-ish to a like 77 or 67, or you might actually be able to change from a 60 to a 70 if you have a remark. Your mark will only ever go up if you do a remark. They don't decrease it. So you either get the same mark or your mark increases. Okay, so for 7.2, they asked to calculate the number of moles of BaOH2 that reacted with the excess NaOH. So now, sorry, I need to do quite a lot of stuff here, because this is what you need to do. This number is a mass, and it belongs to this one. Okay? This number is a volume, and this number is a concentration, and it belongs to that one. If I just color them in, it might help. Then, this number is a volume, this number is a concentration, and it belongs to that one. So if you have a C and you have a V, you can make a number of moles. This is a C and this is a V. Sorry, wrong way around. This is a V and this is a C. And this is a V and this is a C. And then this one is a mass. So you can also get a molar mass from the HNO3. You can get a capital M, and you can get a capital M from BaOH2 if it's required. But if you have a C and you have a V, you can get number of moles, and we need to use the green numbers to get number of moles of BaOH2. So we can do that, I think, fairly easily. So for 3 marks, so basically at the moment, we've got 5 out of the total, which is 18. Then they want the pH of the solution after step 1. So step 1 is when you reacted the nitric acid with the impure MCO3. So basically, to get the pH, you need to know how much HNO3 was left over after step 1. And in order to work out the amount of HNO3 that was left over, the excess HNO3, you take the number that you worked out here, BaOH2, and you use this ratio. So you have the number of moles of this, so then you can work out the number of moles of that. And with the number of moles of HNO3, you can work out the number of moles of H3O+, which then means you can work out the concentration of this, which means you can work out the pH. That's why it's 5 marks. It's slightly more work. So like I said, you use the ratio to work out how much HNO3 was left over, and then the number of moles of HNO3 is the same as the number of moles of H3O+. It's always ratios. Then you work out the concentration of the H3O+. It's in a volume of 25 because 25 of the nitric acid reacted with this, and then there was left over HNO3, which would still have been in a volume of 25. So you work out the concentration of the H3O+, and then that you simply smash into the formula for pH. So if I'm talking to the people who don't know how to do stoichiometry, and stoichiometry is not for them. I just want to show you the marks that everyone can get. The C mark, if you write pH equals minus log H3O plus, and you sub in any number here. So if you weren't able to get the number, you will be able to get the C mark. Everyone can get that mark, and everyone can get the A mark, because whatever answer you got for this question, if you double it, you will get that A mark. So doubling any number that you got in this question. So whether or not you got this correct, if you double it, you'll get the A mark. So everyone can get the A mark and the C mark, which makes it 2 out of 5, which makes it 40%, which means you passed the question. So you guys always say, oh, it's so difficult, it was the most difficult question ever. You must answer every single question and at least put a formula and sub something into it. You need to do that in order for you to get at least some of the marks. If we pass every question, we will pass the paper. You don't need to get all 5, but you do need to get at least using the ratio and writing this formula and subbing in some or other number. You could actually also even get this one to work out the concentration of the H3O plus, because the H3O plus and the HNO3 have the same concentration, because HNO3 has one H. So HNO3 has one H, so each HNO3 makes one HNO3 makes one H3O plus. 3 HNO3 makes 3 H3O plus. So 0.06 HNO3 makes 0.06 H3O plus. So again, now maybe being a bit more generous, but that one, and that one, everyone should be able to get. And if you get this one, you would get this one, and then you would end up with the answer by mistake without even knowing what you're doing. So we're working out the pH after step 1. That means we need to know how much acid was left over after step 1. And we work that out by just using the amount of BaOH2 that reacted, because the BaOH2 reacted with the leftover HNO3. Then there's an even bigger one as a reaction. So for 7.3, it's now 8 marks, which is even more hectic. But again, I don't want anyone to be offended by this. We are not trying to get 8 marks. We are trying to get 4 marks, or even 3 marks. We're just trying to pass it. So the percentage purity, we have already worked out the number of moles of this that we had. We've worked out the number of moles of that we had. We've used these numbers. We haven't yet used these numbers. So let's get some of these 8 marks by working out the number of moles of HNO3. Let's do that. So we see here, you get 1 mark for working out the number of moles of HNO3. So in the first reaction, you had 0.01 mole, and in the second reaction, you use 0.006 mole. So this is how much you had at the beginning. This is how much you had after the reaction. So basically, and I tried this with my grade 11s, I don't know whether it works. If you had 10 burgers at the beginning of the party and 6 burgers left over, what I'm asking you is how many were eaten by this one. The number that you need is not the 10, it's not this number, and it's not the 6, it's not this number. The number that is important is the difference between them. The amount that you had at the beginning and the amount that you had at the end allows you to work out how much reacted with this thing. So you take the amount that you had at the beginning and you minus the amount that you had at the end, and you get 2 marks. You get 2 marks for that. So now we already have 3 out of 8. We have almost 50% for the question, which is great because 50% is almost passing twice. So that is a bit confusing, but there is a concept where the initial amount that you have is equal to the amount that reacted plus the amount that is left over. The initial, which is this number, is equal to the amount that you had left over. This is the excess. This is the initial. And the difference between them is the reacted. And basically, with these kinds of questions, with 2 different reactions, with 2 different sets of numbers, they're always going to ask you. They're either going to ask you, how much did you have at the beginning? how much reacted or how much did you have left over. We already were asked about how much we had left over when we did 7.2.2, because that gave us the pH of the solution after step 1. Now they're asking us the percentage purity of the MCO3, which is terrifying, but basically they're asking how much reacted with this thing. We have how much we had in the beginning. When we use the blue numbers, we get how much we had at the beginning. When we use the green numbers and the ratio, we can work out how much we had at the end. The difference between those two is the number that I want. It's the number that I've worked out here. This is the amount of HNO3 that reacted with the MCO3. So now I can work out the number of moles of MCO3 using the ratio. As usual, we use the ratio, and again, you get a mark. Let's see here. Use of ratio. Not correct numbers, just showing that the number of moles of HNO3, so see here, if you halve it, you get, so if you label your stuff, I can give you the C mark for taking a number that you had for number of moles of HNO3, halving it, and thinking that that is the number of moles of MCO3. Using a ratio correctly will get you a mark whether or not you are using the correct numbers. So then we have a number of moles of MCO3. Now they told us that here it's saying that 85% of 0,198. So they tell you that the percentage purity is 85%. So they're telling you that the impure one, which is this red number over here, 85% of that red number, this is the pure MCO3. We have the number of moles of MCO3, we have the mass of MCO3, we can work out the molar mass of MCO3. The molar mass of MCO3 is 84. We sub in the number of moles and we sub in the mass to get the molar mass. And again, the F mark, if you subtract 60 from a number that you think is the molar mass, you will get a mark. Not for having the correct 84 number. You didn't get a mark for the 84 number. You didn't get a mark for the 0,02. You didn't get a mark for the 0,004. You got a mark for subtracting what you think is the initial from you think is the excess. If you label it like that, you can get the B marks for doing what you were supposed to do, even though your numbers are incorrect. You just need to know what you're supposed to be doing and just label everything. The 60, I know you're asking me where the hell did that come from? The 60 is the molar mass of CO3. So the molar mass of CO3 is 12 plus 16 plus 16 plus 16. So if you minus the 60 from the 84, you get 24, which makes metal M, magnesium. So that was quite a story, but I really do think that all of us can get the A mark, at least one of the B marks, the C mark, because that's simply just a ratio. You can get the D mark, you can do that first. You can do this one before you even do anything else, because you have that number already and you have the 85%. Everyone can do the D mark. Everyone can do the F mark. You must just know kind of what it is you're supposed to do and then label what you're doing. Label that you think that that number is the molar mass and that you're subtracting 60 from it. Great. If you had the correct numbers, that was the correct thing to do. We will give you a mark for it. It's not getting it right. It's just knowing what you're supposed to do.